Hey everyone. So yesterday we talked about atoms and just the intro to atoms. And we were dealing with those mass numbers, protons and neutrons, right? And yesterday I might have gave you something like carbon 12, okay, where this is the mass number, and we determined protons, neutrons, and electrons, okay? Protons we get from the periodic table. I just look at carbon here and I look at the number above and it is 6. Mass number, remember, is protons plus neutrons, okay? And here our mass number is 12. From this upper left number, our protons is 6, so our neutrons must be 6. Okay, and then electrons, we were just saying they were the same as our protons because these are neutral compounds. So that was yesterday. Today, we are now dealing with ions, which are not neutral compound or not neutral atoms. They are atoms with a charge. Okay. So today, we are talking about ions. Okay. I will intermittently say atoms. Atoms means a neutral element. Ions means an atom with a charge. Okay. An atom with a charge. So the way we state charge is mass number was in the upper left corner, now charge is in the upper right corner. So you will get something like O2 negative or something like Na plus. And now these numbers in the upper right corner are our charges. I ran out of room. Charges. Alright, so now you'll start to see combinations of symbols with mass number and charge, like so. Alrighty? So, the main thing that we're going to be doing today is listing protons, neutrons, and electrons based on the charge and the mass number. So let's go ahead and let's look at this. And there is one important rule to know about protons and when we're dealing with charges, okay? The protons do not change. Only the electrons do. Okay, so when we're listing protons and neutrons, it's only the electrons that add or go away. The protons will always stay the same, because if we add or take away protons, then it's no longer the same element more. It's something different. If I have carbon, which has 6 protons, if I add a proton to that, it's no longer carbon, it becomes nitrogen. If I take away a proton from that, it's no longer carbon, it is boron. All right? So let's go ahead and let's do an example and get into this. Let's go back to that oxygen that had that 16 and that 2 negative. I always save electrons for last. All right, I always save electrons for last. It's easier that way. That way you can kind of think in your head how we get the electrons from this charge. So I go ahead and I know I need protons, neutrons, and electrons. And I go ahead, I look at my periodic table for the protons. I go look at oxygen, and right above it is the letter number, 8, okay? The number 8. That means I have 8 protons. Neutrons, we figure out from the mass number. Mass number equals protons plus neutrons again. Our mass number is 16. Protons are 8. So our neutrons must be 8. Okay? Now, electrons, right? We get it from the charge. Remember, protons have a +1 charge. Electrons have a -1 charge, or 1 negative charge. Okay? So, right now, if we had 0 electrons, right, and we had 8 protons, we would have a +8 charge. Okay, that's if we have no electrons. How many electrons are we going to have in order to get a 2 negative charge? Well, let's just start adding electrons until we get to that 2 negative charge. So I could probably guess right off the bat, to make it neutral, I would need 8 electrons to make it neutral. Okay, so now I have 8 protons, 8 electrons, and they're going to cancel each other out because they have opposite charges. But what do I need to get a 2 negative charge? Well, I am going to need 2 more electrons. So I have 2 more electrons. How many electrons do I have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. Alright? So here I'm drawing like a long drawn out explanation just for you to visualize, but from here on out you could say, okay, I got 2 negative charge. That means I have 2 more electrons than protons. Alright, so let's start getting into that habit. Next, let's look at that sodium ion I was looking at. That sodium ion was Na with a mass number of 23 and a +1 charge. Again, I'm going to save those electrons for the end. Protons, I go ahead and I look at sodium, which is over to the left here. You'll get better at finding these as we get going. And it's got a number of 11 above it. So it has 11 protons. Alright? Mass number is 23, right? In order to get mass number, I gotta take protons plus neutrons. Well, my neutrons must have to be 12. Now, here I have a +1 charge, which means I have 1 more proton than electrons. Okay, I can't change the protons, right? I never change the proton, because if I do that, then I no longer have sodium. I have a different atom. So, how many electrons would I need to get a +1 charge? 10. That means I have 1 more proton than electron, giving me that +1 charge. 10 protons take out 10 electrons, leaving 1 proton left over to give it that +1 charge. Let's do another one here. Let's forego the mass number for a little bit, and let's just focus on the charge. Again, I'm leaving this up here because I want you to know, don't change those protons. Let's look at calcium 2+. Again, I'm just focusing on protons and electrons now. I look at calcium. Calcium, I look at the periodic table. It's an alkaline earth metal. It's got a 20 above it, so it's got 20 protons. Here, okay, I have a 2+ charge, which means I have 2 more protons than electrons. So how many electrons would I need in order to give it a 2+ charge? 18. Okay, that means 18 electrons took out 18 protons, leaving me with 2 protons left to give it that 2+ charge. Let's try one that has a negative charge. Okay, protons, once again, I just go to the periodic table. I look at sulfur, which has a atomic number of 16, so it's got 16 protons. And now, electrons. Remember, electrons have that -1 charge, and here it's saying I got 2 more electrons than protons. So if that's the case, the charge on, or how many electrons I will have, will be 18. Okay, 2 more electrons than protons. Never change those protons. Okay, just the electrons. So now gives me that 2- charge. Let's try 3 more. Okay, and then we will be done. And I'll put them all here up top, and if you guys get it, then you get it. Alright, I'll put them all at once. I have AU with a 3+ charge, AU, want to buy a gold chain. I got iodine, 2- charge, used to disinfect during surgeries. And then I have hydrogen +1, that explosive gas in the Hindenburg. Okay, so again, we're just looking for protons and electrons. Let's look at gold. AU, want to buy a gold chain. So, I look at gold, protons. Oh man, gold's a tricky one. It's in this transition metal C. I know it's in here somewhere. There it is, right there. Gold, AU, atomic number 79, so it's got 79 protons. 3+ charge, meaning I got 3 more protons than electrons. So in order to have a 3+ charge, I gotta have 76 electrons to cancel out 76 protons, leaving me with 3 protons left over to give it a 3+ charge. Iodine, I look at iodine, it is a halogen all the way down here. It's got protons of 53, and it's got a 2- charge, so that means it's got 2 more electrons than protons. So I go ahead, I look, I try to figure out how to get 2 more electrons than protons. Well, I'll do that. It just needs to be 55. Hydrogen, this one's a tricky one, easy to find, it's right up top there. It's got 1 proton. Well, it's got a +1 charge, right? Which means it's got 1 more proton than electrons. Well, electrons, that just means I have 0. Okay? You won't ever see a hydrogen by itself. It's always paired with another hydrogen. Okay? So that is ions. Okay, remember, ions are atoms with a charge. So now today what you're going to be doing is you're going to be determining protons from the periodic table, neutrons from mass number, and electrons from the charge. Have a good day, everybody.